So, hello guys, welcome back to my channel, and today I want to presentation again about testing and inspection. Testing and inspection of metals, the quest for quality. So this is my profile, my lecturer, and my subject. So my best reference book is from Metallurgy for Non-Metallurgists, edited by Arthur C. Reardon. So 70.1 metallography. Metallography is the scientific discipline of examining and determining the constitution and the underlying structure. May be done over a wide range of length, scale, or magnification levels, ranging from a visual or low magnification 20 times examination to over 1000 times with electron microscopes. Metallography may also include the examination of crystal structure by techniques such as X-ray diffraction. Some history. The critical factors in light microscopy of metal is the surface of preparation of specimen. This is the basic insight made by the father of the metallography, Henry Clayton Sorby, who is 1863, was the first person to examine properly polished and chemical etched metal sample under the microscope. Hardness testing. Hardness, hardness as a term in use in industry may be defined as the ability of a material to resist permanent indentation or deformation when in contact with an indenter under load. Generally, a hardness test consists of pressing an indenter of known geometry and mechanical properties into the test material. Hardness testing may be classified according to various criteria such as the type of indentation measurement, performance or area or depth, magnitude of the indentation load, last nature of the test or static, dynamic or scratch test. For example, the measurement of the indentation area is used in the Brinell figures and Knoop hardness test. In contrast, indentation depth is measured during Rockwell hardness test. Hardness tests may also be classified based on the magnitude of the indentation load. These tests are often grouped as mi- macro hardness tests with indentation loads, micro hardness with indentation loads, more more so micro hardness testing. Micro hardness tests are commonly performed as an integral part of quality assurance procedures. In micro hardness test testing, loads exceeds 1 kilogram, and the resulting indentation is visible to the naked eye. Tests in this category include the Brinell-Rockwell superficial and figures or heavy load test. The first three are discussed here. Brinell test. The setup for the Brinell test is shown in the picture 7.5 like this, later on the right side. The indentation is measured in millimeters shown and picture 7.5b. A hardness steel or carbide ball 10 mm or 0.4 inch. Micro hardness testing. In the micro hardness testing, loads are less than 1 kilogram and indentation can be seen only the aid of the microscope. Noob and vigorous or low load testing are in this category. Nano-hardness testing. Nano-hardness testing depends on the simulated measurement of the loads and depth of indentation produced by those loads. It has become primarily tool for examining in these films, coating and materials, with surface modified by techniques such as ion implementation and laser heat treatment. And hardness conversion. Because testing labs are often limited in the types of equipment they have available, this limits the types of testing that they can perform. Tensile testing. Next to the hard testing, mechanical testing of the specimen under tension is by the far most common type of mechanical test that is performed. The properties derived from tension testing, as described in Chapter 3 in this book, Mechanical Properties and Strengthening Mechanism, include stress-strain curve showing the elastic and plastic strain gradients of deformation under load. 2. Tensile yield strength, indicating when the elastic limit is reached with some appreciable amount of plastic deform, typically set at 0.2% plastic strain. Ultimate testing strength, or UTS, defined as the cross maximum load at max divided by the original cross section area of specimen. And testing machines. Mechanical testing machines have been commercially available since the late 1880s, and they have evolved from purely mechanical machines such as the popular Little Giant hand crank tensile tester of Tinius Olsen Kirka from 1900 on the picture on the left side. Today's sophisticated machine with either electromechanical gear or servo hydraulic driver provide rapid and precise measurement of loads and disciplines. Fracture toughness. Plastic deformation is in crystalline material occurs by process of shear. See Chapter 3 Mechanical Properties and Strengthening Mechanism in this book. The actual measure shear strength of real engineering material are often several orders of magnitude lower than the theoretical shear strength of perfect defect precursor structure. Fracture toughness testing. With the advent of linear elastic fracture mechanism, engineers now can realize that the design of structure and machines can no longer, under all conditions, be based on the elastic limits or yield strength of a material. Various tests have been developed to measure the fracture toughness of material, and these tests are generally conducted on test specimens containing sharp, pre-existing crack. 5 different standard specimen geometries are specified as ASTM E399. The most fracture toughness tests are conducted with either the H-notch bend or the compact set specimen. 7.5 Impact testing. In an impact test, the specimen is subject to dynamic shock loading to evaluate the response of a material to rapid change in loading, such as that experienced by an axle shaft when a car hits choke hold. A standard impact tester, and this operation we can see in here when a specimen is placed in the path of a swinging pendulum. The pendulum must bend and or fracture the specimen if it too considered the arm. The amount of energy required to break the specimen is absorbed by the pendulum, which reduces the height to which the pendulum rises. The difference between the height to which the pendulum can rise unimpeded and the height which the pendulum rises after breaking the basement. Its accent represents the energy absorbed in breaking the basement. This energy, H strip H accents expressed in Newton meters or joules or J or foot pounds or foot times lb, is called the impact energy of the material being tested. Fatigue testing. For subject to repeat cyclic stress often fail in surface even though the applied stress may be well below the yield strength of the material. These applied stresses may be cycled between tension and compression or between a minimum and maximum value of tensile stress. In addition to magnitude of tensile stress may vary over time. Fatigue is the progressive, localized, and permanent structural damage that occurs when the material is subject to cyclic or fluctuating strains at nominal stresses that have maximum values less than, and often much less than, the static yield strength of the material. In general, fatigue normally consists of crack indentation phase followed by a crack propagation phase. The separation of fatigue process into initiation and propagation phase has been an important observation in transfer to multi-stage fatigue process from the field to the laboratory. Three types of fatigue testing methodologies are commonly used: high cycle or infinite life stress control fatigue testing, low cycle or finite life strain control fatigue testing, fatigue crack growth rate testing based on the fracture mechanism concept of stress intensity K at crack tip, simulation of both crack nucleation in regions of localized strength and the subsequent crack growth mechanism outside of the plastic zone can be produced. Each type of fatigue testing list previously in considered in the context of an underlying fatigue design philosophy. Each type of fatigue testing list is previously considered in the context of an underlying fatigue design philosophy. Stress life or SN fatigue testing for design with a high number of cycles or infinite life design philosophy, or strain life EN fatigue fatigue test for design with low number of cycles, finite life design philosophy, fatigue testing of fracture mechanism specimen to measure fatigue crack growth rates or damage tolerant design of component with existing. So there's stress life fatigue testing is one of the oldest approaches on fatigue testing. Strain life fatigue testing is the general approach employed for continued response in the safe life, finite life regime, and last fatigue crack growth rate testing. Also, although SN fatigue curve have some qualitative use for guiding material selection, the SN approach is subject to limitation primarily by the failure to adequately distinguish between fatigue crack indentation life and fatigue crack propagation life. So there's non-destructive testing. There's various non-destructive testing or NDT and inspection techniques are commonly used to detect and evaluate flaws or irregularities or distinguish or defect in engineering system. Liquid permanent inspection is a non-destructive method used to find discontinuities that are open to surface of solid and essentially non-porous materials. The liquid penetration inspection process is shown in picture 7.26a as 26. A discontinuity open the surface of a symmetrical So guys, thank you for watching my video. Sorry for my misunderstanding words. See you on the next video. Bye bye.